Welcome to Sushmita's Maths class. Here, maths is made so easy and simple that you will all start loving it. Today, we are going to start with symmetry. Symmetry means dividing an image in half to form two mirror images. When two halves of the object are of same size and shape, then objects are said to be symmetrical. For example, you must have seen a butterfly. When it sits on a flower, you cannot make out that it has two wings. That means those two wings are symmetrical. A butterfly is symmetrical. Now, children, the line from which we fold the picture or object, that is called the line of symmetry or the axis of symmetry. If we fold the picture into half, for example, if we fold a leaf from its midrib, or when a butterfly sits folding its wings, the two halves match exactly. They coincide, overlap. These objects are symmetrical. These folds or line which the object is folded is called the line of symmetry. Let's start with a circle. Children, this is a circle. See, we can fold it from any number of lines. Here, we can fold it from here. We can fold it from here. All the places or the lines when we are folding a circle and we cannot see the other half. They overlap each other. So this is the line of symmetry for the circle. So this is the diameter of the circle. So we can draw infinite diameters in a circle. Similarly, a circle has uncountable line of symmetry. Now let's start with some shapes. See, this is a square. When we fold a square, see, we fold it from here. The two sides overlap. They coincide. We fold it from here. They are overlapping. We cannot see the other side. We fold it from here. And we fold it from here. So we can see there are four lines of symmetry. 1, 2, 3, 4. 1 here, 2, 3 and 4. So a circle has uncountable line of symmetry. A square has 4 lines of symmetry. Now, when we push this square a little bit, it becomes rhombus. Rhombus, which has all the sides equal. See, this is a square. When we push it a little bit, it moves like this. All the sides are equal. Only this has bent a little bit. So now this is called rhombus. And see how many lines of symmetry it has. 1 and 2. It cannot be folded like this, because if we fold it like this, we can see the two parts do not overlap. So it has, a rhombus has only 2 lines of symmetry. Next shape is rectangle. See, when we fold the rectangle like this, the two sides are overlapping, two halves are overlapping. When we fold it like this, the two halves are overlapping. But if we try to fold it diagonally, see, if we try to fold it diagonally, they don't overlap. So a rectangle has only two lines of symmetry, one horizontally half and the second one is vertical. Now when we push this a little bit, it becomes a parallelogram. The moment the rectangle becomes parallelogram, what happens? We don't get any line of symmetry, because if we fold it diagonally, see, the two sides are not overlapping. If we fold it horizontally, two sides are not overlapping. They are not overlapping at all. So you can see that a parallelogram doesn't have any line of symmetry. Now we take the different triangles. See, all of you know the isosceles triangle has two equal sides. Isosceles triangle has two equal sides. When you see this set square, see, these two sides are equal. So this is isosceles triangle. So here, this is isosceles triangle. See, these two sides are equal, and when we are folding it like this, the two halves are overlapping, they are coinciding. So isosceles triangle has one line of symmetry. Then we talk of equilateral triangle. This is also called equiangular because all the angles are of 60 degree. Now when we fold it in like this, see, the two halves are overlapping. Then we fold it like this, the two halves are overlapping. Again we fold it like this, the two halves are overlapping. So in equilateral triangle we get three lines of symmetry. See, now let's take up some alphabets. See children, I have written Y in two different manner. Now can you see that this Y has no line of symmetry, but then this Y has one vertical line of symmetry. Now let's take up all the alphabets one by one. If we take A, capital alphabets, if we take A, we have one line of symmetry, one vertical line of symmetry. If we write B, it has one horizontal line of symmetry. C, if written like this, has one horizontal line of symmetry. D, if written like this, has one horizontal line of symmetry. For E, again one horizontal line of symmetry. For the alphabet F, we don't have any line of symmetry. G, we have no line of symmetry. Nowhere it can be folded to make half. Now comes to H. See children, when we are writing H, we have two lines of symmetry. One is the vertical line, another is the horizontal line of symmetry. I, again if we write I like this, we have two lines of symmetry. One is going horizontal and another is vertical. Now J has no line of symmetry. K when written it like this, no line of symmetry. But when we write K like this, there is one line of symmetry. K, then we talk of L, no line of symmetry. M, see here two M's are written in symmetry. One horizontal line of symmetry, one vertical line of symmetry. Now N, here we will write N. It has no line of symmetry. O, children, when O is written like this, it has two lines of symmetry. When O is written like this, a whole circle, then it has infinite lines of symmetry, uncountable diameter of a circle, uncountable spokes of a wheel, so uncountable line of symmetry. Next is P. No line of symmetry. Q, no line of symmetry. No line of symmetry. Next comes S. No line of symmetry. T, U, V, W, X, Y and Z. No line of symmetry. X has two lines of symmetry. Y has one, W has one, T has one, U have one, and V also has one line of symmetry. Children, let's talk about some symmetrical and some asymmetrical objects. From nature, if we want to find out symmetrical objects, we can find out leaf, flowers, butterfly, and children, when we ask for symmetrical objects, many of you write the example of cloud. But cloud, we cannot say it is symmetrical because cloud may be in different shapes. So cloud and tree, usually we say they are asymmetrical objects. Then a number like 1, 0, 1, 1, 0, 0, 1, like 8. So these are the numbers which are symmetrical. You can write 1, 1, 1 also. But the numbers like 1, 2, 3, they are not symmetrical. Alphabets like E symmetrical and F non-symmetrical. Children, we will talk of number of lines of symmetry and the objects or figures where there is no line of symmetry. A scalene triangle, we can say cloud, the alphabet P and the number 2, they don't have any line of symmetry. And when we write 3 like this, we don't have any line of symmetry. When one line of symmetry is there, we can say isosceles triangle AB3, isosceles triangle AB3, written like this, no line of symmetry. Written like this, one line of symmetry. Then 2 lines of symmetry. For 2 lines of symmetry, we have rectangle, then alphabet H and number 8. Then for 3 lines of symmetry, we have equilateral triangle. For 4 lines of symmetry, we have square. And for infinite lines of symmetry, we have circle, O and 0. Children, for some alphabets or some drawings, we tend to think that there is a line of symmetry, but actually there is none. For example, many of us make a mistake of thinking that S has line of symmetry. But just try to draw a line over here and you fold it. You will see this open part comes and overlaps with the closed part. So it doesn't have any line of symmetry. Similarly, N also doesn't have any line of symmetry. Similarly, Z also doesn't have any line of symmetry. We cannot fold it from this line. Then this closed part will fall on this open part, and we cannot fold it like this also, because this closed part will fall on this side. Similarly, no line of symmetry for N. Now tell me, do you think this figure has line of symmetry? See, these look exactly same, but when we try to draw any line of symmetry, if we fold it like this, this open part will come over here. If we try to fold it like this, this open part will come over here. So it also doesn't have any line of symmetry. So when we are confused, we can draw the figure and imagine by folding whether they are coinciding or not, whether the halves are coinciding or not. And in the next, we will talk of mirror reflection. If you found the video useful, do like, share and subscribe, and share it with others, all those who can be benefited.